Okay, number 2 on the practice quiz is the trickier one. The cosine ones, sines are always going to be trickier. Same, you do the exact same math, but yeah, they're going to be a little bit trickier, but not so bad. So let's get started. So find the critical points. Again, that's where the slope is 0 or the slope is infinite. Slope of infinite means we got to have a fraction for our derivative, so the bottom is 0. Last one we didn't have that, and I don't think this one we will either. So let's take the derivative. So y prime is equal to 4, right? 4x goes to 4. Let's see, minus 3 cosine 2x. So derivative cosine is negative sine. So that's going to cancel out the negative. Or I'll just do this one. Minus 3 times negative sine of 2x. And then since it's a 2 in here, we have the chain rule, so we multiply by 2. Obviously, you have to take the derivatives right or the whole rest of this thing is wrong. Be really careful to take the derivatives right. They're not very hard, but it's easy to go wrong if you forget this 2 because there's a 2x here, so you multiply by 2. Okay, let's rewrite this. So y prime is 4 minus a negative is plus. 2 times 3 is 6. 6 sine of 2x. That's our derivative. It's never going to be infinite. We're not dividing by something, but it could be 0. So let's set it equal to 0 and find all the places at 0. And we're only interested between negative 2 and 2.5. This is going to go on. This is a sine, right? So it's going to go on forever. But we're only interested in a small range from negative 2 to 2.5. So we want to find all the max and minimums, and there could be 5 of them, right? Because it goes back and forth. We don't know. There could be 6 of them, could be 10 of them in between negative 2 and 2.5. However, I know there aren't because I chose it. So there wouldn't be. I didn't want to make it that complicated, have that many answers to figure out. So we just look for the ones that are where the peaks and valleys are, the max and mins between 2 and 2.5. So we set this equal to 0, and then we solve for it. So let's see. Put the 4 over there. 6 sine of 2x is equal to 4. Divide by 4. Sine of 2x is equal to 4/6, which is 2/3, is equal to 2/3. Okay, so we want to know all the places where the sine of 2x is equal to 2/3. Okay, so what are the x values where the sine of 2x is equal to 2/3? Okay, so let's just think about what's happening here. Let's do our unit circle. So when is the sine of an angle equal 2/3? Sine is up and down. Sine is the y value, right? Y is equal to the sine. So sine is the y value. And 2/3, we want the y value to be 2/3. So here's our unit circle. This is 1. We want to be, oh, it should be negative 4, huh? Phew, glad I caught that. 6 sine of 2x is negative 4, so actually it's negative 2/3. Okay, so negative, whew, glad I caught that. Negative 2/3 is like down here. So there's 2 places. There's going to be this one, and there's going to be that one. There are 2 places where the sine of 2x, so 2x is negative 2/3 in 2 places. Okay, those 2 places. So if we figure out, okay, so here's then, so basically if we solve this, we say, okay, so 2x is equal to the inverse sine of negative 2/3. So we plug that into our calculator. So 2 divided by 3 is 0.664 negative. Take the inverse sine of that. Inverse sine. And I get 41.8 degrees, except we want to make this in radians. This has to be in radians, so I'm going to change my calculator to radian mode and do that over again. So 2/3, negative 2/3, inverse sine, in radian mode, I get 0.7297, let's say 0.73. So we'll call that 0.73 radians. So it's negative 0.73 radians. So 2x is negative 0.73 radians. Okay, that is going to be this one, right? Right there is negative 0.73. That's negative 0.73. It's negative because it's down, and that's about 0.73. pi over 2, 90 degrees, is about 1.5, right? Pi is about 3, so pi over 2 is, 1.6 or something, 1.56, 1.57, somewhere in there. And so 0.73 is about halfway, so that's about right. Now, what is this one over here? So there's different ways to figure it out. I just like saying, okay, well, here's pi. So this angle here, all the way around like that, is pi plus 0.73. So that's the other angle. Your calculator will only give you one of them. This is why you have to draw this picture, really, to figure out the other one. So the other one is pi plus 0.73. Pi is 3.14. 3.14 plus 0.73 is equal to 3.87. It's 3.87. Okay, so we have two options. We have 2x is equal to 0.73, or we have 2x is equal to 3.87. So, one tricky part, this is why the sines and cosines are tricky, it's this part right here, because your calculator will only give you, when you're always going to find the inverse, your calculator will only give you one answer, the one that's over here. You have to figure out the other answer. And so the best way to do it is just draw this picture every time. When is the sine equal to negative 2/3 here and here? It'll give you this one. You got to figure out that one just by looking at it using symmetry and saying, okay, this is pi, 0, pi over 2 pi plus that much. Here it's 2 pi minus that much, or negative that, same thing. We could have said negative all the way to here and figured that out. Negative pi minus 0.73. And that would have worked too, but I like positives where I can, where it's easy. So, okay, now that's what 2x is equal to. However, it's also that plus, we could go all the way around again, and 2 pi, right? So, and 2 pi more, and 2 pi more, and 2 pi more. So really it's 2x is equal to negative 0.73 plus 2 pi. We can go around and around the circle, because remember, this gives us, oh, and 2 pi times n. N could be, again, n is an integer. N is always, can be dot, 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 negative 2, negative 1, 0, 1, 2, dot, dot, dot. Because it can be any fraction of 2 pi. We can go backwards around the circle. We can, backwards is this way. We can go backwards around the circle, forwards around the circle. As long as we go 2 pi, we end up in the same part. So numbers of 2 pi. And same as here. Here, plus 2 pi, plus 4 pi, plus 8 pi, or minus 2 pi, minus 4 pi. So plus 2 pi n. We do this before we solve for the x. 2x can be those things. So x then, we divide both sides by 2. Okay, so I'm running out of room to do that. But if 2x is equal to that, and I'll erase my n here just so you know that is, then what is x? So divide everything by 2. So x then is equal to negative 0.73 divided by 2, which is negative 0.365 plus pi n, because divided by 2, get rid of the 2 pi. And then down here we have, or x can be this one, 3.87 divided by 2, which is 1.935 plus pi n. Okay, those are all the places where there's maximum or minimums. However, we only care about between negative 2 and 2.5. So we got to figure out which of these numbers fit between negative 2 and 2.5. Okay, so let's figure that out now. Negative 2 and 2.5. So let's look at this one first. Negative 0.365 sure does. That's in between negative 2 and 2.5. How about, can we take away, remember n can be negative 1. Can we take away pi from that? That would give us, pi is about 3, right? That would give us negative 3.365. That's bigger than negative 2, so that's not one of them. So one of them is negative 0.365. How about if we add pi to 0.365? Okay, so this n equals 0 gives us negative 0.365. N equal negative 1, that's too big, right? That's negative 3.4 or something. How about adding pi? So 3.14 plus, minus 3.14 minus 0.365 equals 2.775. That doesn't fit. So this first equation only gives us one, negative 0.365. Because if we added pi to that, it's too big. It's over 2.5. So we only get one. How about this next equation? 1.935 works. It's smaller than 2.5. So we know we get a 1.935. How about if we take away pi, right? Always take away, that's the n equals 0 solution. If we take away pi, 1.935 minus pi is negative 1.2. And that works. That's in between negative 2 and that. So we also have another one, negative 1.21. That's close enough, negative 1.2. How about if we add pi? Then that's clearly too big, right? Because this is about 2. If we add 3, it's going to be like 5, and we only want to go 2.5. So there are 3 points. Unfortunately, there are 3 points in the range that we care about. Not just 2, there's 3. So it starts off with negative 1.2. So putting them in order, we have negative 1.2. We have negative why am I negative way in the bottom there? Negative 0.365 and then 1.935. So 2 of those are going to be maximums, 2 are going to be minimums. You know, one in between, we don't know which way it's going to go. Right? It could be something like this. A maximum, a minimum, and a maximum, or it could be the other way, a minimum, a maximum, and a minimum. We don't know, so that's the next step to figure this out. Okay, and figuring it out is easy. Again, let's just do the second derivative. Second derivative here is pretty easy. So we'll do the second derivative test. Let's see, I'm going to block this out here. The second derivative test, so y double prime is, y prime is this, the 4 goes away, that's super nice. Derivative is 6 sine 2x is 6 cosine 2x times 2, so 12 cosine 2x, so it'd be 12, yeah, it's positive cosine of 2x. So again, derivative of 4 is 0, let me check that, derivative of this is cosine 2x times 2 because it's 12. Okay, so second derivative is 12 cosine 2x. So all we got to do then is plug those things in, see if it's positive or negative. So what is, we plug in negative 1.2. So remember, calculators have to be in radians. They're talking radians here. So that would be 12. We don't even need the 12, right? Because it's all we want to know if it's positive or negative. The 12 doesn't matter, but what the heck, I'll put it there. So that's cosine of 2 times negative 1.2, so cosine of negative 2.4. Make sure your calculator's in radians. So 2.4 negative cosine times 12. I don't really have to do the 12, but I get negative 8.85, which means if it's negative, that's a maximum. The slope goes from positive to negative. That's a maximum. Therefore, this one should be a minimum, and that one should be a maximum. You can't go any other ways, right? So those have to be, so it has to be max, min, max. If we plug this in, we should get positive. If we plug that in, we should get negative. Let's just try one of them just to check and make sure. So let's try negative 0.365. So that would be cosine of 12 times cosine of 2 times negative 0.365. And make sure calculator's in radians still. 2 times 0.365 negative cosine times 12, and I get 8.94. So sure enough, it's positive, so that's a minimum. And if we did that for 1.935, we'll probably get it to maximum. Okay, so I'm going to write over here that this one, the first one is a max, and this is a min, and this is a max. Now, the only thing left is to figure out what the y values are, which is kind of a pain. We got to plug these numbers back up into our original equation, so that way we can graph them again, so we know how big our graph is, right? So we got to figure out the y numbers. These are the x numbers. So these, I'm going to do it this way. So these are the x's. Let's figure out the y's. Again, it's just a calculator problem. Plug in negative 1.2. Make sure it's radians when you plug it in to this thing here. Okay, so it'd be 4 times negative 1.2. So I'm just going to do it all on my calculator. Let's see. 2.4 negative cosine times 3 negative plus 4 times 1.2 equals. And I think okay, this is where you got to be really careful. I'm running out of room here, so where should I do it? I'm going to do it way up here, so it's easy. Okay, we want to plug in 1.2. So 4 negative 1.2 times negative 1.2 minus 3 times cosine of 2 times 1.2, so it's negative 2.4. That would be, this is, I can do this in my head, that's negative 4.8 minus cosine of negative 2.4, 2.4 negative cosine radians times 3 equals, so it's minus negative, so it's actually plus 2.2, because I got negative 2.21 from this, but it's plus it. So 2.2 plus 4.8, so that's equal to negative 2.6. Okay, how about next one, negative 0.365. So 4 times negative 0.365 minus 3 times cosine of 2 times negative 0.365. Okay, a lot of calculator work. Did I say that already? 0.365 times 2, 0.73, negative 0.73 minus 3 times that, so 2 times 0.365, negative cosine times 3, negative minus 5.6, negative minus 5.6. Let's see. Wait a minute, what's going on here? 4 times negative 0.365. How did I get 0.73? Let me try that again. 0.365 times 4. What the heck? It's 1. Okay, you got to be really careful with these. Negative 1.46. Negative 1.46 minus 5.6. So that's negative 7.06. Ooh, that's pretty big. That's a pretty big y value there. So now let's plug in 1.935. That's pretty big. Now let's make sure this makes sense. This is a max. So it goes negative 2 down to negative 7. That makes sense. Our next one better be bigger than negative 7. And that's where we plug in 1.935. So 4 times 1.935 minus 3 cosine of 2 times 1.935 equals, okay, 2 times 1.935 cosine times 3. That would be, this is, do that again. 2 times 1.935 cosine times 3. This is negative 2.2, but it's minus a negative, so it's actually plus. So plus 2.24, and then 4 times 1.935. And this is 7.74 plus 2.24 is 9.98. So it's definitely bigger, 9.98. Okay, so our points then are negative 1.2 comma negative 2.6, and then it goes to negative 0.365 comma negative 7.06, and then finally, I'm going to draw a line here, and then finally negative 1.935 comma 9.98, and this is a max, and this is a min, and this is a max. And can you see all that? Okay. Okay, so this isn't showing up very well in the, yeah, hopefully you can read that. All right. So that is the first part. Again, these things can take a long time. Now we know all the points, the x and y values, so we can graph them. And now we got to figure out the endpoints. So when -2, so when x equals -2, what's y? So y is equal to 4 times -2 minus 3 cosine of 2 times -2, which equals, see, -8 cosine of -4. Sure it's in radians. Cosine times 3. I get minus 1.96, which is -9.96. And when x is equal to 2.5, y is 4 times 2.5 minus 3 times cosine of 2 times 2.5, which is 5. So what's cosine of 5? That times 3. So I get, that's 10 minus 0.85, which is 9.15. So 9.15. Okay, so these points then are -2, comma, -9.96, and 2.5, comma, okay, hopefully you can see all this. Yep, I think I'm under the camera now. 2.5, comma, 9.15. Okay, so what are the global ones? What are the biggest positives and biggest negatives? Let's look at the biggest one, the biggest y value, -2.6, -7, 9.98, that's pretty big. This one's big too, is 9.5, the 9.98 wins. So this one up here is a global max. So 1.935, 9.98 is the biggest it's going to be. That's the max. Global maximum means the absolute, the overall biggest. There's other maximums. This is the overall biggest. That is the, and then the overall smallest, the most negative one. See, -2.6, -7. This endpoint, right? This endpoint's -9.96. So at one of the endpoints at -2, it gets the smallest, -9.96. So on our graph, we got to make sure that we go all the way up to about 10 and all the way down to about -10. And then it should work out pretty good. Okay, I think that you can see this better now. It's kind of, the lighting's kind of weird right now. Yeah, I think that works better. Okay, so that's the idea. A lot of work. Yes, I keep saying it's a lot of work. It is. Okay, now finally, moving on. The inflection points. Again, the inflection points are where the second derivative is equal to 0. Y double prime is equal to 0. Now, it could be one of these types of things. That's the inflection point. Y double prime is equal to 0 there. And it switches over from concave up to concave down. Inflection points are where it switches over from concave up to concave down. Yeah. So it's possible it can be something like that. But if we know what's in between a maximum and a minimum, then we know what's our regular inflection point. So we just need to figure out where the second derivative is 0. We already figured out the second derivative, which from earlier is 12 cosine of 2x. We want to know when that's 0. Divide both sides by 12, that's when the cosine of 2x equals 0. So when is the cosine of 2x equal to 0? Then we draw our circle. Okay, so cosine is 0. Cosine is the x value. Okay, cosine is the x value. So it's 0 here and here at pi over 2 and at 3 pi over 2. And then of course, now, okay, here, since these are, here's a cool thing, since these are only pi apart, all we need to say is pi over 2 plus pi, plus pi, plus pi, plus pi. So we don't really have to have two separate answers, because if they're both pi apart like that, then we can just say pi over 2 plus pi. So when does that happen? When is the cosine of 2x equals 0? That's when what's in the parentheses here, when the 2x, what's in the parentheses, is equal to pi over 2 plus pi or minus pi. So plus n pi. So we get 2x is equal to n times pi. Sorry. It's equals pi over 2 plus n times pi. Yep, that makes sense. So, or you could say take the inverse cosine of both sides. We could do it that way. So this is, so 2x is equal to cosine -1 of 0. If you said cosine -1 is 0 on a calculator, what the inverse cosine of 0 is, it'll tell you that it's pi over 2. Okay, so it'll give you the pi over 2. And we know from our picture that it's not just pi over 2, it's pi over 2 plus fractions of pi, plus pi, plus pi, plus pi, or minus pi, minus pi, minus pi. That's what the n pi gives us. So 2x is equal to pi over 2 plus fractions of pi. Okay, we want to know what x is. Divide both sides by 2. X is equal to pi over 4 plus n times pi over 2's. Okay, those are all the ones. We got to find all of those now in between our interval, in between -2 and 2.5. Okay, how many n's, what n's fit there? Let's make this decimals now because pi over 4 and stuff is confusing. So pi divided by 4 is 0.785, close enough. So x is 0.785 plus n times pi over 2. Pi divided by 2 is 1.57. So I'm going to say 1.57 n. I like to put the n second. Plus 1.57 n. Remember, n can be 0, it can be negative. It's always like -1, -2. Okay, 0.785 works. Okay, so I'm write down our possibilities here. So we have 0.785. That works. How about we add 1.57? So let's add 0.785 to 1.57 plus 1.57. That's 3.14. Wait, that makes no sense. 0.785 plus 1.57 is 2.355. That works. So n equal 1 works, right? So we get 2.355. That's another one. That's n equal 1. N equal 2, there's no way, because that's pi. If we add a number to pi that's bigger than 2.5. But 2.355 is less than 2.5. That works. Now, how about if we take away pi? Let's say n is -1. So 0.785 minus 1.57. Let's try that. So 0.785 minus 1.57. I get -0.785. That works. -0.785. That's n equal -1. We go -1.57. And how about n equal -2? So that would be pi. It's 0.785 minus pi. Let's try that out. So 0.785 minus 3.14. That's -2.35. That doesn't work. That would be -2.355. We only go to -2. So once again, there are 3 that work. These are the x values here. We have 0.785, 2.355, and -0.75. Those are where our inflection points are going to be, and it should match up in the graph where it looks like it's kind of in the middle of the peaks and troughs. Okay, where is the graph concave up? Okay, the best way to do these now is to graph it. Let's just graph it. We have all the points. We can just look at our graph and see where is it concave up, where is it concave down, where is it increasing or decreasing. So we want to graph all the important points. So let's see. Where's my first paper? I think I buried it. So where's my first side? Oh, sorry, that was it. I was thinking that was the other one. No, we're good. Okay, so remember we want to go to -10. We showed this before. We want to go all the way down to -10 and 10. So on my graph, we'll put the very bottom here is -10, and the very top, about the same distance, is +10. And we go from 2 in this scale to, let's see, this is 5. And so this would be 1, 2, 3, 4, something like that. Oh my gosh, so 2 is going to be so small. It's going to be like right here. So -2, and here's +2, and this would be like 3. So here's 1, 2, here's 3. So 2.5 is like right here. So this is going to be a pretty small graph. Okay, so our points are at -2, it's negative 9.96. So it's really close to -10. It's right here. There's 1 point. At 2, -2 is 9.96. At 2.5, it's 9.5. So 2.5 right here, it's pretty close to 10, 9.5, something like this. And then our maximum is at negative, at 1.935, it's 9.98. At 1.935, less than 2, it's a little bit higher than that one. So let's say it's right about there, just about 10. That's our peak, then it goes down. And then we have one more at negative 1.2, it's negative 2.6. Negative 1.2, negative 2.6. So here's 1, so here negative 2.6. So something like, here's negative 2, something like that. And at negative 0.365, it's negative 7.06. Negative 0.365. Negative 6 goes down. So here's negative 5, negative 7. It's going to be something like this. Okay, so we have all the max and mins. Should have 5 points. The endpoints, and then the 3 max and mins. Okay, now we got to draw the picture. So it goes like this, goes down, goes up to here, that's a maximum, goes down to our minimum, goes up to our maximum, which is right there. It's pretty tricky to draw. So it goes up, here's our minimum, goes up to our maximum right there. I'm going to go down like this, see if I can make it hit right about there. And then it goes down to here, and then that's the end of our interval. We cut it off at 2.5, which is right there. Right, that's all we care about. And then here's all we care about, negative 2. It goes there. Okay, now the inflection points. My guess is there should be one right around here, and there should be one right around here. And let's see, where are they? So there's one at 2.355, so there's one right there. Right there is inflection point, just right in between those 2 points. And then there's one at 0.785, so here's one, so right about here, so it looks like right about there is inflection point, which makes sense. It gets steeper and steeper to less and less steep. And then there's one at negative 0.785, so here's one, so right about here, which is right about there, which makes sense. Those are the inflection points, about halfway between the peak and the troughs, roughly. Not always. This one is not quite halfway, right? The peak is way up here. But that's, we can mark the inflection points, and that's how we can now say about concave up and concave down. Here it's concave down, here it's concave up, here it's concave down, and it's from inflection point is where it switches over. And we can also say where it's increasing. Okay, concave up. Up is from here, from this inflection point to that inflection point, right? Concave up. This inflection point was negative 0.785. So we would write here negative 0.785 to the next inflection point, which was 0.785. That's concave up from here to here. And that's it. Here it's concave down. Here it's concave down. So just that one place from inflection point to inflection point. That's where it switches over from concave up to concave. That's the definition of inflection point, is where it switches over from concave up to concave down. So from here over it's down. From here to there it's up. Okay. How about where is it decreasing? Where is the graph negative? So all we got to do is look at it, right? The slope is negative from here to here, from peak, trough, that peak to that trough. So we look at our values here. Those are x equals, the first peak is at negative 1.2 to negative 0.365. So negative, what did I say, 1.2. We always just put the x values here, to negative 0.365. Okay, that's here, this part here. And then it's also negative at the very top, from our peak to the end point. The last peak was at x equals 1.935. So 1.935 to 2 to the endpoint. We only went to 2, right? No, we went to 2.5. Sorry. So we went to 2. It's negative 2, but to positive 2.5. So 2.5. That's the other place it's negative, from the peak to where we stopped graphing it. So 2 places where it's decreasing. And again, if I had said increasing, you would just have said from here to here and from here to here. And if I had said concave down, you would have said from the endpoint to this inflection point, and from this inflection point to that inflection point. Actually, you know what? I forgot something. We have an inflection point right there. So that means from there to the end point, it's concave up. I forgot a concave up, because from inflection points over to the next inflection point, it's concave up. Well, ours ended, but since our inflection point fit in there, the inflection point was 2.355, we have to have another concave up here. It's 2.355 to 2.5 to the end point. This very last little part there, from that inflection point to here, it's concave up. So we just have a little tiny bit of that. It would have kept going like that too. There'd be another maximum. If we kept graphing it, there'd be another maximum and a minimum. It'd just keep looking like this, but going on forever, up and up and up. Okay, that's our graph. Again, if we did this on Desmos, it should look very similar. And so just by using calculus, we can make a really good graph and know all the important things about this function. Okay, this stuff is tricky. Especially all the sines and pi over 2s and n pi's and stuff. So you really have to be careful, draw the circle, and you really have to be careful what you get, and then it should make sense. Inflection points should be about where you'd think they'd be, in between the peaks and valleys and all that kind of stuff. So, okay, so finish this on your own. Like, make sure to write all this out, then I'll give you some more practice, and if the practice goes well, we'll take a quiz on this stuff, then we'll be done with curve sketching.